initially I want to define implicit form, and as per my note, it is definition 12. If the function, complex function defined, which maps z1, z2, z3 into omega 1, omega 2, omega 3, then we have one implicit form or linear fractional transformation. Then the formula is omega minus omega 1, omega 2 minus omega 3 upon omega minus omega 3, omega 2 minus omega 1 equal to z minus z1, z2 minus z3, z minus z3, z2 minus z1. How we remember this? We remember this 1, 2, 3, 3 to 1. 1, 2, 3, 3 to 1. 1, 2, 3, 3 to 1. How we remember this? Okay, this is the formula 1, 2, 3, 3 to 1. That's where we will remember. We start with one example, 14, as per my notes. Find implicit form which maps z1 equal to minus 1 into omega 1 equal to minus I, z2 equal to 0, omega equal to 1, and z3 equal to 1, omega 3 equal to I. This is the formula that we know. Now we put this value in this one, and by putting this and by simplifying this one, we will find the actual function. Let's proceed. Okay, how it is? Omega minus omega 1, that is omega minus of minus I, that is omega plus I. Omega 2 minus omega 3 means 1 minus I. Omega minus omega 3 means omega minus I. Omega 2 minus omega 1 means 1 plus I. In this side, z minus z1, so it is z plus 1. z2 minus z3, 0 minus 1 means it is minus 1. Z minus z3 means z minus 1. And z2 minus z1, and therefore it is plus 1. Now we proceed further. Therefore, w plus I one minus I, w minus I, 1 plus I equal to 1 plus z upon 1 minus z. We give this minus sign to denominator. Now what we are doing right now, we are using compared angle. First we simplify this term. So it is omega minus I omega plus I minus I square omega plus I omega minus I square. So this is equal to 1 plus z, 1 minus z. Therefore, omega minus I omega plus I plus 1 omega I omega minus I plus 1 1 plus z 1 minus z. So right now minus I square is what? Plus 1. We put this value minus I square is plus 1, nothing more. Now we use compare to dividend to. Means we add denominator and numerator in numerator. Therefore, omega I omega plus I plus 1 plus omega I omega minus I plus 1 upon omega I omega minus I plus 1 is equal to 1 plus z 1 minus z upon 1 minus z. Denominator plus numerator upon numerator. Denominator. Numerator plus denominator. Denominator. Numerator plus denominator. Denominator. So the ratio is balanced. Both these are cancelled. Both these are cancelled. 2 omega plus 2 omega I omega minus I plus 1 equal to 2 upon 1 minus z. Now we are going further in the simplification, so we can cancel out these 2, and due to that it is 1 there. We cancel out 2 from both this side. Then we multiply w plus 1 into 1 minus z cross multiplication omega I omega minus I plus 1. Omega minus z omega plus 1 minus z omega I omega minus I plus 1. So now we cancel out the same terms from both this side. Okay, omega omega will be cancelled. This plus 1 is here, plus 1 is there, so it will be cancelled. So what we have right now, I minus z equal to I omega plus z omega. So it is I plus z omega. See here, we transfer the sign of this minus sign on that side, and therefore it is plus I. This is minus z, minus z. I omega is there, yes it is, and we transfer the side of minus z omega on that side, and therefore it is, if we take the omega in common, it is I plus z, and therefore I minus z is this, and therefore omega is I minus z I plus z. And this is final answer. Here, dear friends, here we start with example 50. Find implicit form which maps z1 equal to 1, 0, minus 1 into I, infinity and 1. So infinity is new concept here, and for that we use one manipulation there. common from numerator and denominator. Now if we put omega to infinity means this is 0, this is 0. So now this term is not there in calculation. So we have only this thing are there for our calculation. And therefore we proceed after this equation, and therefore it is omega minus omega 1. So here omega 1, we put the values directly we put the values omega minus I and omega minus 1 equal to z minus 1 and z2 minus z3, so it is plus 1, z plus 1 minus 1, and therefore we have, so here this is omega minus I means it is omega 1, omega minus omega 3 means it is omega minus 1, z minus z1, z minus 1, z2 minus z3 means 0 minus of minus 1, so it is plus 1, z minus z3 means z plus 1, z2 minus z1, and therefore it is minus 1. So this is equal to 1 minus z upon 1 plus z. So we use this minus sign to transfer value of numerator. Therefore omega minus I 1 plus z is omega minus 1 minus z. Therefore omega z omega minus I z omega minus z omega minus 1 plus z. So it is omega plus z omega minus I z omega minus z omega minus 1 plus z. Now we cancel out the same values from both this side. We transfer this from that side, so it becomes 2z omega. This is 2 z omega plus z omega. This is equal to I plus iz plus z minus 1. This is equal to I plus 1z I minus 1. This term is here, and therefore omega is I plus 1z plus I minus 1 upon 2z. We get our answer. Now if you see the example number 10 and 11, In example 10 and 11, we do the same sums by Mobius transformation. In this method, we do the same sums by implicit form. You can find both answers are same. So we proceed further in the same. We say that a function is conformal at a point z0 if its derivation at there is not equal to 0. But that indicates so many things. These are the tangents and these are the angles. Suppose this is C1 and this is C2. And the image of that under some mapping is a C1 dash and C2 dash. And this angle, if you draw at the point of intersection, and if this angle is remain the same, difference of angle, then such a mapping we call it conformal. Such a mapping we call it conformal. Clear? That is about necessary and sufficient condition for conformality. Prove that an analytic function fz is conformal at z0. Double implies that derivation at z0 is not equal to 0. So we start with the part 1. F dash z0 not equal to 0. Omega equal to fz, and if I write as a parametric equation, omega t is f of zt. Now omega dash t is f dash. Now here we apply chain rule. Now if we do it this at that point t0, then it will come. Now we apply chain 0, omega dash, f dash, and then z dash. Very well known formula. Therefore, argument of omega dash t0 is argument of zt0 plus argument of zst0. Now if we say the argument of zst0 is argument z0 dash, phi 0 that is argument of omega 0 dash, that is argument of omega dash t0, and psi 0 that is argument of f dash zt0, f dash z0. Now if there are two curves C1 and C2, be two smooth curves are passing through z0, let theta 1 and theta 2 be two angles of inclination of direction line tangent to C1 and C2. Now where they match, that we have to show, that we have to see, and we have to show to make it conformal using the property of conformal. Therefore, psi 0 plus theta 1, phi 2 is psi 0 plus theta 2. And therefore, if you take the difference, we are using this formula here. Taking the difference, and therefore phi 1 minus phi 2, theta 1 minus theta. You understand this is pre-angle, difference of pre-angles, and this is post-angles. The difference is the same, means angle preserves, means function is conformal. In the second one, f is conformal, differentiation is not zero. Second part is very easy and very good. You can find it there. Just write it. You will find your solution. Clear? With this note, I stop here, but you have to do lots of practice of writing practice. If you write it so many times, you will understand it very clearly. Thank you very much.